everyone, this is Precious T. Sharma, and today we learn about minimum spanning tree. Okay, minimum spanning tree. So to find the minimum cost of spanning tree, we use Kruskal and we use Prim. Okay, so let's try to solve this problem first using Kruskal, and then we'll use it with Prims also. It will be more clear that way. Okay, so let's do it with Kruskal first. First, we note down all the vertices. So we have 4, 3, 6, 5, 1, and then 2. And since we have how many vertices? 1, 2, 3, 4, 5, and 6. So number of vertices are 6. Then in best case we have edges. How many? N minus 1. N is vertex. So this means 5. And that's when we should know when the edges are 5 that we should stop. Okay. So in this, first let's see which one has the minimum edge. We'll go with the minimum edges. This one has the minimum. Okay, so we'll connect this and then 1. Okay, wait. One. Then let's go back to this. Then we have 2. Okay, so no problem because after 1 there will be 2. Now we have 3 here also and 3 here also. So which one should we choose? So we have to make sure that a loop is not forming. So we did 1, we did 2. If we choose this 3 like this, then a loop will form, which we don't have to make. So we'll go for this 3. Okay. After 3 we have 4 here. 4, then we have 5 this. 5. Now 7. Oh, did you notice? If we go for 5, a loop is forming, which we don't want. So we can't use 5. Okay, we have to make sure that no loops are forming in this. So we will not go for this because a loop will form. So after 5 there is no 6, then we'll go for 7. After 7, if we go for 8, again a loop will form. That's why we'll not go for 8. And we'll then check for 9. So if we do 9, yes, a loop will form again. So we'll not do it. And we don't even have to check so much further. We'll just count the edges. 1, 2. Wait. Let's do it with that. How many edges are there? 1, 2, 3, 4, 5. We can just stop here because we know that 5 is the maximum and n minus 1. Okay, So we don't have to check for like we did for 5, then 7, then 8 and 9. We don't need to check it. No, till 7 it is okay. Then for 8 and 9 we don't need to check if we count the number of edges, and since they are already 5, we don't need to go further. So let's count the cost of minimum spanning tree. We don't need to do much. We just need to add all these edges. So it's 4 plus 1 plus 2 plus 3 plus 7, and it is 3, 7, 10, 12, 13, 17. So 17 is the answer. Now let's start with Prim's algorithm now. So we'll use the same problem. Okay, so what we did in the cruscals, we took all these vertices and then we connected the edges in the increasing order, right? In Prim's algorithm, we can take any vertices, whichever you want. Let's start with 4. Okay, and from here we see the adjacent edges. What are the adjacent edges? These. And we'll see which one is the minimum with 4. So we know that 1 is minimum, so we'll make 1 here and then 1. So now with 1 we know that we have 2 and we have 4, but we'll also check these previous adjacent vertices too. So for example, let's imagine if this was 4, not 2. So we would have taken this one because 3 is the minimum out of all. Okay, but here since in the problem it's 2, so we'll take 2. Now we reached here, so we have 3. We can't make this 3 because a loop will form, so we'll just remove it because it will be a lot of confusion now. Then so we have 7, 3, we have 5, we have 9 and we have 4 also. So we'll go for 3 because this is the minimum. Now with 3 also we have 8 and we have 5. We can't go for 5 because again a loop will form if we go for 5 here, right? So we'll not use this. Oh, and we also have 4, and out of okay we have 9, we have 4, we have 8 and 7 also. So out of all of these, let me use different color. Out of these 4 is the minimum, right? So we'll go and do it. This is 5 and edge is 4. So now we'll not make this because again a loop will form, and we'll check. Okay, and this vertex is left. We can't leave any vertices. We have to include all of them. So 7 is there and 8 is there, right? So we'll go for 7. And yeah, for the minimum cost we don't need to do anything. We'll just calculate these edges. So 4 plus 1 plus 2 plus 3 plus 7, which is equal to 3, 7, 10, 17. Did you notice something? Here also it came 17 and in this also it came 17. So it doesn't matter if we use any of these, the answer will be same for both. So we can use any of them. We can use cruscal also, we can use Prim also, and even in the Prims we can, in this we took from 4, But if you want to take from 6 or from 5 or from 1, we can take it from any. The answer will always come same. So if you want to recheck it, you can again go for, you can again like check it from the different vertices and check if the answer is coming the same or not. If it's not, then you must have done some mistake. Yeah, so that's it for now, guys.
I hope you like this video. Thank you.